What's going on, guys? Mal here. Figured I'd do a demonstration of my board mounted ringer so you can see how simple it is. It's all mounted on a portable board for demonstration. It now runs off of a 14 volt DC supercap or battery. I will hook it up and you will see what it can do. So the design is getting much more refined and much more powerful. So there it is. Make sure we're all in frame. Hear it ringing away. Also in this video, I will show the ringer passing through a full bridge rectifier, rapidly recharging capacitors. So the ringer is powering up this bulb to more than full intensity, over 40 watts. That's our current draw. Two and a quarter amps to get that bulb very bright. Again, we will zoom out, give you a good view. Everything's portable on a board. Can be no complaints, no one whining about anything. And in this video, I will also be connecting this circuit up to a full bridge rectifier composed of the correct diodes that will allow a capacitor bank to rapidly recharge, and we can run very large loads with nearly no input power. I'm going to demonstrate the circuit outputs a lot more power over time than the input draws, completely silencing the crowd that keeps making noise and telling me there's nothing special about these circuits. No, they're completely wrong. The circuit is wound on a ferrite core laced with metglas. That's what makes it so special. And I call it the ringer because of the sound it makes. When the core reaches saturation, it will ring. And the circuit also generates small amounts of wireless power. If I connect this to anywhere, right here you can see the wireless power being generated off this guy. If you bring in a ground connection, it can be a rod in the ground, a plate in the ground, or an earth connection, and if you put a bridge rectifier between the negative of your source and the earth ground, you'll also get free power there. So there's another source of free power, and now in this video I will back the camera up. Well, actually next I will hook up a rather large load to show you what the circuit can do, because it's been upgraded. And if you accidentally short the output out, you will blow the transistor. You don't really want to draw more than 90 watts from this guy. And this might take a minute to light because it's a heat bulb, but once it gets warm enough it will light. It'll definitely light with the capacitors. You just got to get it ringing. I would like to demonstrate that on camera. Come on, it will light. No, I'm having difficulty, but it should light this. I'll try it a little bit more, and if it doesn't, I'll stop. Okay, I'm having trouble, so again, I'll hook back up the light. It definitely will run when I add the capacitor bank. So that 40 watt light runs full power. And while it's doing that, I'll try and quickly connect the bulb. Come on. No. Alright, it's being picky, but sometimes it can run that bulb. Now, anyway, you can see that. It's completely portable. Can be no complaints about it. You can lift it up. Power passes through meters. Completely portable. So, next I will disconnect and hook it up the correct way. So, the correct way to use this without saturating the core and getting the ringing sound is to have it go through a rectifier and then charge caps. Just have to make sure the polarity is correct. And I'm filming all this live without editing or cutting anything, so people can't complain. Now the only issue is I'm not sure if that polarity is correct. I'm gonna have to check it with a voltage meter, so I will be right back. Alright, got the voltage meter. I just want to make sure the polarity is not wrong when I charge those caps. So I'll hook it up. We will see if our polarity is correct. So here's the output on the rectifier here. So the polarity is correct. 93 volts DC. Now notice that we're getting that rectified DC while placing a minimal strain. Now the caps are charged. We are placing a minimal strain on our input. Look how much power we're drawing on the input. Almost nothing. We're almost drawing no power on the input. Less than 2 watts. And we fully recharge this capacitor bank. The voltage in this cap bank is I'm gonna back this up so you can see everything. So now we sent the output from the ringer. We're using it the correct way. The output is going through a full bridge rectifier to recharge a DC capacitor bank. Now, I will connect up the bulb. I'll leave the meter connected so you can see how quick it recharges. And you can see our input in frame too, hopefully. So again, to sum it up, that 14 volt DC super cap passes through a current meter, powers up our ringer circuit. Our ringer circuit outputs high frequency, 500 megahertz on this version, is upgraded, outputs high frequency. Excess power comes from the fact it's wound on a metglas laced ferrite rod. And then we use that power to the high frequency rapidly recharge the capacitor bank. Now I'll take that power and we will run a heat light in pulses. This is the correct way to use the power. You would then step down this high voltage DC, 100 volt to 120 volt DC. You'd step it down to 12 or 14 volts, pulse discharge it into a battery that you would recharge to then run an inverter, and you're off running. And as you see, our input is virtually nothing. And watch when I do this. Look how bright that is. And our input never spikes. We're recharging this capacitor bank with virtually no input. This circuit will output far more power over time than your input drain. And I'll repeat that. This circuit outputs far more power over time than your input drain, which is virtually nothing. And again, wait 5 or 10 seconds, and we're powering up a 100 watt halogen load. So we're using 1 or 2 watt on an input, and every 10 seconds we get 100 watt pulse. That's crazy. And not to mention, while we can do that, we still have the wireless power effects present that we didn't even play with in this setup on the board yet. If you bring in a earth connection and you earth the negative of your capacitor bank, your cap bank will charge much quicker because you establish a reference point with the ground, and the negative is grounded of the cap bank, so it will recharge quicker. And again, and that's the input current draw to the circuit. Virtually nothing. We're not ringing because we didn't saturate the special core. We're using the power correctly in pulses. Again, you would step down this power with a DC to DC buck converter. You would step down the 100 to 120 volt DC to 12 or 14 volt DC, run it through a timer circuit, which would pulse discharge maybe 10 amps for 0.1 seconds every 2 or 3 seconds, like this. This is how you recharge your batteries with the special timer circuit. See how fast those caps are recharging? And our input doesn't even spike. This is more power output over time than the input. I don't know why people don't understand that. You can literally see the raw current here sparking. Our input meter isn't even pegging as long as we don't fully drain these caps. Now I will fully drain the caps and let you see what happens. Now the core will reach saturation and we will draw power. As you see, the core has reached saturation and we are drawing power on the amp meter. This is the incorrect way to use the circuit. That's smoking, I'm gonna have to take that off. Ooh, that's really hot. Now anyway, you saw that demonstration, the correct way how to use the ringer. The fact that you can recharge capacitor banks very rapidly, virtually no current drain on your source. So I demonstrated that. That should shut the skeptics up. It's our ferrite rod with the metglas laced in it that allows for that effect to happen. And again, here's the pulse. And this bulb will come on full power, 40 watt pulse every 1 or 2 seconds, and we're still accumulating a charge in the caps when we do this. $40-watt pulse every what, 3 seconds? And if I really let this sit, build up to 100 or so, you can really see what's going on. I'll even light up this big 200-watt halogen with that cap bank. And I didn't even enhance this by messing around with the wireless power I can harvest from this thing. And I didn't even add an earth connection. I didn't even ground the negative rail of the capacitor bank. Alright, so we hit 100 volts on the caps. That bulb looks like it wants to pop. You run a bulb on DC versus AC, it'll be brighter. And again, we're doing that pulsed power with a virtually no input. That's the input drain to the ringer, right there. In fact, I will even try and zoom in on that, but when the bulb flashes with brightness, it kind of washes it out. And I am using a tripod, so we will see. Virtually no drain. Virtually no drain on the input. The white light effect is kind of screwing with the camera though when it flashes. Next, I'll let it charge up a bit, and I will connect the 200 watt halogen. And this video is a demonstration video to shut the skeptics up, prove the proof of concept, showing you we didn't even optimize the system yet by messing with the harvesting of the wireless power here, or by earth grounding the negative of the cap bank. And again, to sum it up, your input source powers up the ringer. The ringer's high frequency, and the fact we're using an exotic metglas rod, the high frequency rapidly recharges a capacitor bank with virtually no input, and then you're off running and you can do whatever you want with it. Now I will hook up this very bright bulb, 200 watt. No problem. We'll even leave it hooked up and watch what happens. Now we place a drain on the system because it is detuned. I'm showing you now the power of the system, how the transistor will no longer blow under heavy loads. You just can't short it out directly, then it will blow. We are drawing now, what is that, 4 amps from a 14 volt DC source. So it's about 50 or 60 watts here, and it will smoke, and you hear it ringing because we've saturated the core of the ringer. That is hot. So this video is demonstrating to you it's portable, it's on a board. Again, to sum it up, 14 volt DC source, could be a battery, could be a super cap, powers up the ringer generates high frequency. The fact it's wound on a ferrite rod laced with metglas allows you to rapidly recharge a DC capacitor bank after passing through a bridge rectifier. You then take that power, 80 to 120 volt DC, you step it down via a DC to DC boost converter to 12 or 14 volts DC. You then use a timing circuit to pulse discharge it into batteries, and your excess power, you use your excess pulsed power at 14 volts to fully recharge big batteries, and then from those big batteries you power up an inverter, and you can run pretty much whatever you want, whatever your heart's content is. You would then power up a inverter, 120 volt or 240 volt, you're good to go. And I don't have my ground wire handy in this location, but if I were to have grounded the negative of my capacitor bank, this would accumulate a charge much quicker without putting a strain on the input source. And again, we also didn't even screw around with the wireless power effect. You can see this slightly glowing just as I get it near the capacitors. I'm not even touching the capacitors yet, and it's glowing because we have wireless power coming from the ringer. So that's that, and we will end it with the bulb running. interesting effect occurred. It's almost kind of like the capacitor now is maintaining its charge while running the bulb at half power instead of full power versus no capacitor bank. We are drawing 1 amp on the input, and that's our bulb that's lit. The ringing has been silenced with the capacitor bank. So you can use this thing to very efficiently charge up, to charge batteries, big batteries, for off-grid applications. And you bring a heavy ground connection in, you're in business. So that's a full demonstration video. Here's a good look at the rectifier. Give you a good zoom-in view of all the components. A little bit of a long video to explain things and shut the annoying skeptics up. So, skeptics will always tell you you can't have more power out than in. Well, that doesn't account for pumping devices. You can also prove them wrong by saying, if free energy doesn't exist, run outside holding a metal rod in a thunderstorm. Mother Nature will set you straight real quick. And over 100% efficient heat pumps are undeniable. So, this device, somehow using high frequency, combined with the metglas laced core, and a ground connection on the negative, and if you properly harness the wireless power off of this thing, you will have all the energy you need in life. So, that's that. I sell these things, the ringers, $150 a pop. You just get the ringer, the upgraded version that can run off 14 volts DC. $150. Everything else is sold separately. You just get the ringer, and you don't want to exceed a 14 volt DC 6 amp input. That's really pushing it. And again, it won't blow unless you directly short out the output leads. The output leads are the white wires. Your DC input leads are the red and black, and the output is the white. And I had to make this special diode configuration, full bridge rectifier, put 2 in series, to get my DC voltage up to about 100 volt DC to store real charge. Once you get into high voltage, it becomes hyper efficient, over 100% efficient wireless power. And the reason for that is you get an accumulation via the environment. So, similar to how an unlimited amount of people can tune into a radio station without bogging down the radio signal, or without putting a strain on the radio station itself, without drawing power from it. So, that's that. Full demonstration, full explanation how everything works. We're using high frequency to rapidly recharge a cap bank, and somehow the system siphons excess power from an earth connection, generates small amounts of wireless power. The circuit is hyper efficient, and yeah, also to my knowledge, no one's ever wound a super joule ringer 3.0 circuit on a ferrite rod laced with metglas. So, that's that, and feel free to like, subscribe, comment, support the Patreon. Even if you don't support the Patreon, feel free to join it. There's so much free electrical content on there. So much books, so much knowledge of all the masters from ancient to modern. All for free. You can download it, read it for free. You can do whatever you want with it. Huge library of knowledge all in one spot for free. And yeah, schematics too, how to build it. Nothing is held back or restricted on this channel in any way. The schematics on how to build this are on my Patreon for free. I also sell the ringer as a fully complete kit you can purchase. So, you're seeing everything it can do right here. We'll back up a bit. So, this is where it's being run. The board can completely move. I just don't want to short anything out and cause a small explosion, because I can easily combine now. I can easily build 2 or 3 ringers, combine the output from that same source. I can run banks of light bulbs if I want, charge batteries, have excess power, and keep the system going. And I hope that fully explained everything. As you see, the board can fully move. So, that's that. And thank you, everybody. That was just a quick, well, not that quick, but it was a full explanation of everything. And once again, sum it up. Input source powers up the ringer. High frequency rapidly recharges your caps. You negatively earth ground your caps. They charge quicker. You step the voltage down to 12 or 14 volts DC, pulse discharge it into a load. And you would need the special timing circuitry, which is right here. This is what my timing circuitry looks like. These both were bought off Amazon. So, pretty simple stuff. Literally just transforms the power into something more usable to recharge 14 volt DC batteries. This was like $5 off Amazon, this was 10. So, none of this stuff is that difficult. And yeah, that's that. Once again, thank you everyone. Feel free to like, comment, subscribe. And I think I will show that it can run LED lights too. Not only can we run halogens and incandescents, we can also run LEDs. That's hot. LED spotlight, 9 watt. 9 watt, 120 volt AC. Very bright. Extremely bright. Lighting up my whole room bright. And we still have wireless power. So, the capabilities of the ringer are almost endless. And that LED draws such a small amount of power, we're hardly straining the input. So, that's that. And thank you, everybody. Stay tuned, because things are getting very freaking interesting.